From nuclear physics, we are discussing about the radioactivity. In previous lecture, we discussed about the partial radioactive decay. Friends, in this lecture, we have to see successive disintegration of a radioactive nuclei. The radioactive nuclei are disintegrate with the time. The original radioactive atom or nuclei is known as a parent. The parent is a disintegrate. That is the emission of alpha particle, beta particle or gamma radiations from the parent's atom, so that we get a new atom by disintegration, and it is known as a daughter atom. The daughter is also disintegrate and we obtain new daughter. This process is carried out up to the end product is stable, or we obtain stable end product which is not radioactive. So if we consider A is one of the radioactive atom or radioactive nuclei. Now this radioactive nuclei disintegrate, okay, and we obtain atom B. This atom is known as a parent atom, okay, which is the original radioactive atom. Now parent is disintegrate into the daughter, okay. The daughter is also disintegrate and we obtain new daughter, that is a daughter C. This process is carried out up to X, which is a stable atom, okay. If we consider N1 is a number of radioactive nuclei of a daughter, of a parent. Now this parent is a disintegrate, okay. Lambda 1 is a decay constant for this parent, okay, and we obtain the daughter atom, okay. N2 is a number of radioactive nuclei for the daughter atom. Now this daughter atom also disintegrate and we obtain new daughter, okay, which have the radioactive nuclei N3. Decay constant for this daughter is lambda 2. Now this process is carried out up to which the last end product is a stable end product. Now, according to law of radioactive decay, the rate of disintegration of a radioactive nuclei rate of the disintegration of radioactive nuclei is directly proportional to number of radioactive nuclei present at that instant. If we consider the parent atom, okay, which is the original radioactive atom, so the rate of disintegration of a parent can be represented as dN1 divided by dt. This is the rate of disintegration of a parent, which is equal to minus lambda 1 into N1, because we can say that dN1 divided by dt, which represent the rate of disintegration of a parent, is directly proportional to the number of radioactive nuclei present at that instant, and so it is equal to minus lambda 1 N1, okay. According to law of radioactive decay, we know that the radioactive nuclei disintegrate exponentially with the time, and therefore the number of parent atom N1 can be written as N0 e raised to minus lambda 1 into t. Okay, this represent number of parents atom. Okay, n0 is number of a radioactive nuclei when time t is equal to 0. n0 is the number of radioactive nuclei when time t is equal to 0, or original radioactive nuclei. Now the daughter, we know that the parent disintegrate so that we obtain a daughter, and daughter is also disintegrate, okay, so that we obtain new daughter. Okay, the rate of disintegration of a daughter, can be written as dn2 divided by dt. It is equal to lambda 1 n1 minus lambda 2 n2. Here the first term lambda 1 n1 represent rate of formation of a B, or we can say that rate of formation of a daughter, and the second term lambda 2 n2 represent the rate of a disintegration of a daughter. Okay, so this is dn2 divided by dt is a rate of disintegration of a daughter. It is equal to lambda 1 n1. The first term represent the rate of formation of a daughter from the parents. Okay, and lambda 2 into n2 represent the rate of a disintegration of a daughter, or n2. Okay, and here again we can say that the radioactive nuclei disintegrate exponentially with the time, and therefore we can say that the number of radioactive nuclei for daughter, it is equal to p into e raised to minus lambda 1 into t. Okay, this is the first term, plus q into e raised to minus lambda 2 into t. Okay, this represent the number of radioactive nuclei for daughter atom. Okay, so again, if we consider when time t is equal to 0, the parent has not decay, so n2 is equal to 0. Okay, and therefore we can say that even t is equal to 0. Okay, t is equal to 0, and therefore n2 is equal to 0. Okay, when we put the value, that is the number of radioactive nuclei for daughter, it is equal to 0. T is equal to 0. That is when there is a initial time. Okay, there is only a parent atom is present. When the parent is disintegrate, we obtain daughter, which have the radioactive nuclei n2. Okay, but when t is equal to 0, there is only parent atom n1. Daughter is equal to 0, and therefore t is equal to 0, n2 is equal to 0. When we put here, we get p into e raised to minus lambda into 0. This represent e raised to 0. Here e raised to 0. E raised to 0 means 1. Okay, so this term is 1. This term is also 1. So p plus q, it is equal to n2 is also 0, and therefore we can say that p plus q is equal to 0. It indicates that p is equal to minus q, or simply q is equal to minus p. Okay, q is equal to minus p. We can represent like this, and therefore n2 is equal to p into e raised to minus lambda 1 into t minus p into e raised to minus lambda 2 into t. Okay. Take p common, we get p in bracket e raised to minus lambda 1 t minus e raised to minus lambda 2 t. Okay. Now, the rate of a disintegration of a daughter. Rate of disintegration of a daughter. And we get, when we represent rate of disintegration of the daughter, that is a dN2 divided by dt. Taking a derivative of this term, okay, p in bracket e raised to minus lambda 1 t means minus lambda 1 e raised to minus lambda 1 t. Okay, so its derivative is a lambda 1 e raised to minus lambda 1 t. Okay, derivative of second term, here this lambda 1 and this lambda 2 minus lambda 2 and this minus sign, it became plus. So plus lambda 2 e raised to minus lambda 2 into t. Okay, so this is the derivative of this term. Okay, now, but we know that d rate of disintegration of a daughter, it is equal to, if we consider this is equation number 1, okay, from equation number 1, from equation 1 we get, okay, here is a lambda 1 n1 minus lambda 2 n2, it is equal to p in bracket minus lambda 1 e raised to minus lambda 1 t plus lambda 2 e raised to minus lambda 2 into t. Okay, so this is one of the equation. Okay, now if we consider t is equal to 0, then the number of radioactive nuclei, that is number of radioactive nuclei for parents n is equal to n0. Okay, and there is no formation of a daughter. Okay, and therefore we can say that number of radioactive nuclei for daughter is equal to 0. At an initial time, when t is equal to 0, the number of radioactive nuclei for parent, it is considered as n0. And if there is a n0 number of radioactive nuclei for parents, the parents is not a disintegrate, so that we does not obtain daughter, and therefore n2 is considered as 0. Okay, now when we put the value here, okay, we get, this is lambda 1 into n0, lambda 1 into n0. Here lambda 2 into n2 is 0, so this term is not here, so it is equal to p in bracket. Now t is equal to 0, so it became e raised to 0. E raised to 0 is 1. Here is again e raised to 0, it is 1. So here this term is a lambda 1 plus lambda 2. Lambda 1 plus lambda 2. Or simply we can say that lambda 1 into n0, it is equal to p in bracket lambda 2 minus 1, lambda 2 minus lambda 1, and therefore p is equal to lambda 1 n0 divided by lambda 2 minus lambda 1. Okay, lambda 2 minus lambda 1. Putting this in this equation. Okay, we know that N2 is equal to P in bracket e raised to minus lambda 1 into T minus e raised to minus lambda 2 into T. And therefore N2 is equal to P, value of P is N1 into lambda 1 into N0, lambda 2 minus lambda 1 into e raised to minus lambda 1 into T minus e raised to minus lambda 2 into T. This equation represent number of daughter atom, which is radioactive. Daughter is also radioactive. Now this daughter is also disintegrate, okay, and we obtain new daughter. Okay. So this process is a successive disintegration of a radioactive nuclei. Again, successive disintegration of a radioactive nuclei. The original radioactive atom is known as a parent. The parent is a disintegrate, so that we obtain daughter. The daughter is also radioactive, so this daughter is again disintegrate and we obtain new daughter. This process is carried out up to which end product is stable, which is not radioactive. If we consider N1 is a number of radioactive nuclei for parent. Now this parent is a disintegrate and we obtain daughter which have the number of radioactive nuclei N2. Lambda 1 is a decay constant for the parent. Now this daughter again disintegrate, okay, so that we obtain new daughter. This process is carried out. The rate of disintegration of a parent can be written as d lambda d n1 divided by dt is equal to minus lambda 1 into n1. Okay. The radioactive nuclei disintegrate exponentially with the time, and therefore we can say that the number of radioactive nuclei for parent n is equal to n1 is equal to n0 e raised to minus lambda 1 into t. If we this is when t is equal to 0. Now the rate of disintegration of a daughter, when parent is a disintegrate we obtain daughter. The rate of disintegration of a daughter can be written as dn2 divided by dt is equal to lambda 1 n1 minus lambda 2 n2. The first term represents the formation of daughter, while the second term represents the disintegration of the daughter. Okay. The number of radioactive nuclei for the daughter can be written as n2 is equal to p e raised to minus lambda 1 into t plus q into e raised to minus lambda 2 into t, where p and q are the constant. Okay. If we consider initial time t is equal to 0, there is no formation of daughter and therefore n2 is equal to 0. Okay, and therefore p plus q it is equal to 0. Okay, there it indicates that p is equal to minus q, or simply we can say that q is equal to minus p. When we put this value, okay, in this equation, we get p in bracket e raised to minus lambda 1 into t minus e raised to minus lambda 2 into t. Okay. Now take derivative of this term, okay, so that we obtain rate of disintegration of the daughter. Okay, so derivative of first term is minus lambda 1 e raised to minus lambda 1 t plus lambda 2 e raised to minus lambda 2 into t. Okay. Now from equation 1 or equating this equation and equation number 1, we get this term. If we consider t is equal to 0, n1 is equal to n0 and n2 is equal to 0, same condition is here, and therefore lambda 1 into n0 it is equal to p in bracket lambda 1 plus lambda 2. So lambda 1 into n0 p in bracket lambda 2 minus lambda 1. Therefore p is equal to lambda 1 into n0 divided by lambda 2 minus lambda 1. When we we know that the number of radioactive nuclei for the daughter N2 is equal to P in bracket e raised to minus lambda 1 into T plus minus e raised to minus lambda 2 into T. When we put the value of P, we get this N2. Okay, N2 is equal to lambda 1 into N0 divided by lambda 2 minus lambda 1 into e raised to minus lambda 1 into T minus e raised to minus lambda 2 into T. This represents the number of radioactive nuclei for the daughter atom. Okay. In next lecture, we have to see the ratio of activity of a parent to the daughter and different types of equilibrium. Thank you.